Hello friends and welcome to another tutorial on Geeks for Geeks. In this tutorial, we are going to cover separate chaining, which is a collision resolving technique in hashing. This video is in continuation with our previous video on hashing where we introduced hashing and its related concepts. We would therefore request you to have a look at it before moving on with this one. Let's take few of the concepts we discussed in the previous video. Hashing. It is basically a technique used to index and retrieve items in a database in a reasonable amount of complexity. Hash function. This function maps a bigger string into a smaller one, which is now used as an index in our hash table. Next, we also discussed collision. Since we are using a hash function that gives us a smaller number or string from a key, there is a possibility that two keys result in the same value. The situation where a newly inserted key maps to an already occupied slot in a hash table is called collision and must be handled using some collision handling technique. We see collision through an example. Let's say our hash function is x mod 7, where x is our key to be mapped. Then these two values of x will give same value, which is 4. Hence we say that a collision has occurred. Now to handle this collision, we have two techniques. The first method is separate chaining and the other is open addressing. In this video, we will discuss about separate chaining. This technique of separate chaining makes each cell of hash table to point to a linked list of records that have the same hash function value. Now to understand this in detail, let's have a look at an example. Let's consider a hash function h of x which is x mod 7. Here x will be the key which we want to map to. Now the range of this function will be 0 to 6. So we have a hash table as shown here. Let's also have some keys which we will try to hash. We start with first key. 50 mod 7 is 1. We put 50 in the slot with index 1. Next, 700 mod 7 is 0. We put 700 in slot with index 0. Next key is 76 and 76 mod 7 is 6. So we put 76 in slot with index 6. Next is 85 and 85 mod 7 is 1. Now we have a collision. We have already put 50 in our slot with index 1 and therefore cannot put 85 in it. So what we do is we create a slot and link it to the slot with the same hash values. We therefore link slot with key 50 to the slot with key 85. Next we have 92 and 92 mod 7 is 1. Again a case of collision. We add one more node to our linked list with hash value 1 and this is how it will look. Next we have 73, mod 7 of which is 3. We therefore put 3 in slot with index 3. The last key is 101 and 101 mod 7 is 3. Again a collision. We create a linked list of hash values 3 and add a node to it with key as 100. So This is how our hash table will finally look like. Now, let's have a look at some of the advantages we have in separate chaining. The first is that it is a very simple method to handle collision and therefore can be implemented easily. Next advantage is that the hash table can grow and we can add new elements to it. Another advantage is that the hash table is less sensitive to the hash function use. The last advantage is that the method can be used easily when we are not aware of the number of operations that need to be done with the keys. Now let's also consider few disadvantages we have with this method. The first disadvantage is about cache performance, which is not so good as compared to open addressing. Next is the wastage of space. These space are the slot of hash table which are not taken by any of the keys. Another disadvantage is that if a majority keys hash to the same values, then linked list grows and the access time becomes big O of n in worst case. The last disadvantage is that we have to waste extra memory to save the link addresses. Let's finally look at the performance of the separate chaining. For this, we define load factor alpha, which is n by m, where n are the number of keys and m are the number of slots in hash table. This load factor is basically average number of keys per slot, given an assumption that each key is equally likely to be hashed to any slot of table, independent of where other keys are hashed. So, the expected time to insert, search, or delete will be big O of 1 plus alpha. That is, pay 1 to apply hash function and access slot, and then pay alpha to go through the list. With this, we come to an end of this tutorial. If you have any doubts or suggestions, please leave them in the comment section below. Thanks for watching.